Hello everyone, I'm Ravi Verma, co-founder and CTO of IMESH Technologies. In our last two sessions, we went through creating and configuring Kubernetes cluster in Azure and AWS. In today's session, we'll go through application deployment in Kubernetes cluster. But before directly jumping into deployment, let's try to understand few key concepts which would be needed during our development. Okay, so first in the list is pod. So what is pod? Pod is the most basic deployment unit within a Kubernetes cluster. So that we'll understand a little bit more. We'll dig into a little bit of deeper and I'll try to explain. So let's first go through the definitions and all, and then we'll go into that. And it is a group of one or more containers, basically closely related containers with shared storage and network resources. That we'll see like what that means. It contains one or more application containers which are relatively tightly coupled. Basically, related containers can go within a pod. So let's try to understand a bit of what it is. And okay, so we can have this one we can consider as P1. It's a pod. Okay, it can have multiple containers within it. Suppose C1, C2, C3, and all of this they can share a common storage, so they can share and access. So pod is a logical grouping of containers, and they can share and communicate with each other. So we can imagine this one as a kind of a logical host. That pod is a logical host, and C1, C2, C3 as kind of processes running on the particular VM or PC, if we want to relate it to. And they can communicate with each other using local host. So suppose C1, the container one is running on port 3000. C2 is running on suppose 5000. And C3 is running on 8000. So if C1 wants to communicate with C3, so that directly it can do localhost to 8000 port, and that C1 will be able to communicate with C3. If C2 wants to communicate with C1, it can access directly port 3000 or loop back like localhost 3000. So that way they can communicate within each other. So that's on high level, it's a pod. Okay, so yeah, so that's the pod, and they share a common IPs. So like if it is connected to a network cluster, so they'll be having some IP, and they all share the same IP. So suppose this 10.200.198.50. So all these containers will be sharing this IP. So that was meaning of sharing a network and sharing the common storage. Okay. So now coming to a part. So suppose one application is running in a cluster, and now we are getting more traffic. To handle more traffic, we need to have multiple instances. Like we need to scale it further. So usually what happens in industry, we have two kinds of scaling we do, either vertical or horizontal. But vertical scaling is not kind of infinite. We cannot add more and more hardware to an existing system, PC. So it is having some limitations. It cannot go beyond that limit. So then comes the second option is a horizontal scaling, in which what happens, we add a new system into our cluster, and then we can spin up new instances of the application on new instances of the PCs. So that way we can scale. So when traffic comes and when the load increases, we can have multiple instances to handle that traffic and serve the request. So in that case, what happens? So like P1, it will have another. So we'll have another pod, that is P2. And again, it will have some IP. 200, 198, suppose P4. So now this P1 and P2, they can communicate with each other using these IPs. Fine. Okay, so now comes the problem. So suppose we want to scale it in a manner like when the traffic increases, we need to scale it, and then when traffic decreases during certain time, we need to decrease it further. That is, descaling need to be done. So in that case, if we go only with pod approach, we need to do it manually. Like we need to create multiple pods again and again and again. And when the requirement goes down, we need to delete one by one, one by one. So to handle this scenario, we have another construct which is called deployment. So that is next in our list. So deployment provides a declarative update for pods and replica sets that we'll discuss a little bit in more detail. So what happens in deployment? Usually we instruct a Kubernetes like this. These are the pods need to be created. These many pods need to be created. And this is the image for that. Like take this application and create those many replicas. So we need to only write at one place, and all those replicas will be created and will be handled by deployment. So we can imagine the deployment as a manager for the pods. So basically, we can have a deployment which handles all pods creation and maintaining the state. So suppose, for example, if one of the pod dies, so that is the responsibility of deployment to recreate it and provide connectivity, like basically recreation and scaling down. If the need arises to scale down, that need to be handled by the deployment. So we need not to do it manually. So that part is getting handled by deployment. Okay, so now we have two problems. Basically, if we have multiple instances running, we will run into two problems. One is like like one pod we can consider as a one microservice. So one microservice want to communicate with other microservice, and that way we can have thousands, hundreds of microservices. They'll be needing to talk to each other, and each microservices can have multiple instances running, and they need to communicate with each other. So we will have two problems. One is we need to know the IP. We need to know the IP of a particular microservice to which we want to communicate. That is first problem. Second problem is if the same microservice, so let me draw it, explain it a little further. So suppose we have instances of multiple microservices. Now, these are connected to a network, and there are few other microservices. They want to communicate. So what happens if this microservice want to communicate to these like set of instances of microservices? This guy need to know the IP. So in that case, what will happen? This IP need to be somewhere, it need to be remembered. But what happens when a pod dies and when it is recreated, the IP changes. So definitely it is changing the IP, and then that cannot be maintained very easily. And that is not a good way also for the communication. So what happens to handle that situation? We have a next construct in our list that is called service. So, and how it solves the problem, we'll see that. So an abstract way to expose an application running on a set of pods as a network service. It means it provides a single endpoint for other microservices to communicate to a set of pods with single endpoint. Like we need not to know all the IPs of all the pods. Only one IP or one name will be enough. So that is a service, and service provides a single entry point for all the similar pods. That is first thing. Second thing is it is having IP, like it's kind of a stable IP. It does not change until unless that service is deleted. So even that node goes down, node comes up and all, that IP will be still the same. And it has a name also. The DNS, it gets a name. So we can access the service with IP, either IP or with the name. So in other microservices, if we want to communicate, so let's again go here. So what happens? We have a service here. So if this microservice want to communicate, this guy will only talk to this service. And this service, so responsibility of services, first thing is the providing a single entry point. Second responsibility of services to load balance it. Basically, if it is running 4 replicas of the same application, so it is responsibility of service to load balance the traffic within all pods. So that is the second responsibility. It is done by the service. So that's where we need a service. Now we have majorly four kinds of services provided by Kubernetes. So first one is cluster IP. We'll discuss more detail of it. Cluster IP, then we have node port, then we have load balancer and external name. So we have majorly 4 kinds of services. We'll talk about it a little bit in more detail. So first one, so this, whatever I just explained, this is a cluster IP service. It means it gives a cluster-wide IP address, and it allows other microservices to communicate with other set of microservices, like set of pods. So if this is also one set of pods which is managed by a service, let me draw it with the color. So this is cluster IP1, cluster IP2. So now, if any one of the pod want to communicate, will communicate with cluster IP1, and if any one of the microservices from this set want to communicate with this set of another set of microservices, so it goes through cluster IP2. So with this, we are solving 2 problems. One is like we'll have a stable IP or name. The second thing is the load balancing part is also solved. So that is done by cluster IP. So that cluster IP provides a means to communicate with other microservice within the cluster. So if we are using a cluster IP microservice, we cannot access it from the outside of the cluster, but within the cluster, we will be able to communicate with each other using cluster IP. Now comes the second part, the node port. So it is very less likely in real world, we'll have only the microservices which are talking to each other within the cluster. Definitely we'll have, most of the cases, we'll have a need to communicate to the application which is running inside the Kubernetes cluster from outside. So that's where we have another service called node port, which is built on top of cluster IP. So how it is? So now, explain a bit. So how it works? So suppose we have a node. So suppose we have two nodes, N1 and N2. We are having applications running here and here. So with the help of node port, what happens? It creates a port on the node, which is called node port here and here. So it's a kind of entry point to the node port. So if one want to communicate to any applications running within this node, we will be using this IP of this node. So node gets also one IP, like it is in an external network, either private or public, and external user can communicate to this port if a request need to be sent. So that can be accessed using node port. So it is accessible from outside on this specific port. So for that, what happens? But still it is having a few limitations. Like we need to know the IP of the node. And like if we are having more nodes, so we need to handle to which node we want to send a request. So that's the problem with node port. And one more problem with node port, not problem, it is having few limitations. Like it is having a node, the port need to be assigned in a particular range, which is 30,000 to 32,768. So that's the range of the node port. So we cannot choose any other port number outside that range, which is 30,000 and 32,768. So that's another limitation. So as we saw, we have a problem with node port accessing it from outside. We need to know the IP and we need to know the port as well. To solve that problem, we have another service which is called load balancer service. Load balancer service is basically, it is designed on top of node port, and it handles, basically it distributes the request. So let me make it a little smaller so I can. Okay. So when we create a load balancer service, in that case, load balancer creates an external load balancer, and a network traffic goes through that load balancer, and load balancer's responsibility to split the traffic to a specific node, or basically distributes the traffic. So it is a load balancer's responsibility to distribute the traffic to a specific node, or basically balance the node. Basically, all the requests will be balanced throughout the. So we need not to select a particular node to send the request. So our entry point will be only node balancer's IP here. We need to know the IP of the load balancer, and then we are done. Load balancers also have few limitations. So to handle that limitation, we have ingress, but that will not be talking in today's session. The ingress will be talking in the next session. So we'll be explaining what is ingress, how it works, and how it overcomes the problem of load balancer. So basically load balancer, or for that matter, any service, basically they are linked to a set of pods, or basically set of services. So suppose we have multiple services, microservices, and they are like each services are having suppose five instances. So suppose we have 10 microservices of different types. In that case, we need to have 10 load balancers to access this from the outside. So that creates a basically more cost. We need to, for each load balancer, we need to pay extra cost, because each load balancer will be connected to a load balancer, external load balancer, which incurs a cost. So that's where we need the ingress that I'll be explaining in next session. Okay, so that's all about service. We have external name also, one service, which is used basically in the case where we want to use an external application. Suppose we have a database running in our another, like outside of the cluster, and we still want to access that. So there we can use external name. So in external name, we provide basically domain name, basically the URL of the service, and within the Kubernetes, the application, the microservices, they'll be still thinking that is still running inside the cluster. So that way we can bring the external microservices, connect the external microservices or external services to a cluster within bringing it, like without bringing it exactly inside the cluster. And later, and this provides a kind of wrapper, one level of wrapper, so that in future, if you want to migrate that service within the cluster, the other applications which were talking to that external applications need not to change, need not to worry, because in that case, only service will be changed from external name to within any cluster IP, something like that. So will not have any other impact to any other microservices, those who are using that external service. Okay, so now we'll move to demo application. We'll see like whatever we discussed throughout now, we'll be using that one to deploy the application in a cluster. Today's we'll be deploying it in AWS cluster, which we had created earlier in our last session. And then we'll see how to deploy, how to communicate. So let's go towards that. And let me connect to a cluster. Okay. So we have a EKS demo cluster already we had created. I'll be connecting it. So we have two options to connect. Either we can connect it from our terminal, which we saw in our last session, or we can go directly from a cloud cell provided by AWS. So basically it is provided by all the cloud providers usually. So let it connect. Fine. So let's create a folder. So first we'll be creating a pod, we'll be deploying it, and then we'll try to get access to it. Basically, we'll try to connect to that pod and see how it works. Okay, so let's create first pod. So let's name it simple pod. And yeah, one more thing to note, we have multiple ways to deploy to a cluster. One of the ways using a declarative approach, in which we write a YAML file and we define what all the things need to be done. Like it is kind of configuration. So we tell this is the configuration, and then we submit it to Kubernetes, and Kubernetes cluster takes that one and then performs the necessary action. So we'll be taking that path today. And other parts like we have Helm chart and operators, all other options are there, but we'll be going to only this option today. Okay. So let's create it. No need to worry about the syntax, all syntax for now. Wherever required, I'll explain, but no need to worry about all the syntax. We'll go through it in more details in future sessions. Even find we need to give pod as we are creating pod. Then we need to have metadata. So we can give a name to this pod basically. So let's give it engine X pod. And let's give a label. This label will be used by the service to basically provide the connection between service and pod. Levels. Suppose it's any, it's just key value pair. We can give anything on left side and the right side. So I'm giving just a demo for. After that, we need to give a spec. Spec is a specification. Basically, we are telling now Kubernetes what need to be done, like what all the images need to be taken and what will be the port. So that will define here. So for simplicity, we'll be using one container per pod. So to make it simple. So we need to define containers. Containers, we can give any name. Suppose I'm giving engine X. Then we need to give an image, like which image, which Docker image. So basically the image what we provide here, it's a Docker image. And it is currently pulled directly from the public repository, which is Docker Hub. So by default, it pulls the image from Docker Hub. If we have any other repositories that we need to give, in that case, we need to give a full name, like full URL. So image, we can give engine X. And then we can give a basically a label, a particular tag, we can give it. So 1.4, I am giving. Then we need to specify ports. So container port is basically on which port this particular pod will be accessible, like accessible from the outside. Outside means any other ports or any other microservices on which port they'll be able to communicate. So that will be giving 80 default port. Okay, so let's see if any other ports are already available or not. So we'll see. So with kubectl get ports. We don't have any ports running currently in default namespace. So let's go and create it. kubectl. Okay. So pod is created. Now we can see it. Pods. So we can see now it is created and it's running. We can get a more information if you want to get IP of this particular pod. What we can do, we can run the same command with wide option. It gives a little bit of more information, like what's the IP of this particular pod and on which node is this running. So we can get how many nodes are there connected to kubectl. So we have two nodes currently, and this particular pod is running on 255 on the first node. Fine. So with this, we will not be able to access it like I cannot access it from the outside because this is not in the same Kubernetes cluster. So for that, we need to, if we want to test whether that IP, whatever we created, this IP that like in the theory we discussed, right? Like the pod, we can communicate with one pod to another pod with the IP. So let's try that one and then test it, whether it is really working or not. So for that, what I'll do, I'll create another pod and I'll try to connect. I'll connect to that pod. Basically, I'll enter into that pod and then we'll try to connect to a second pod. So for that, let's modify or create a copy of that. Simple pod 2. For that, I'll just change the name here. So now we should be seeing two pods running. So we are having two pods running and we can note the IP. So what I'll do, I'll enter into one of like exec or enter into one of the pod and then I'll try to ping or access the another pod from here. So let's try to connect to this pod. Basically, I'm trying to enter into that pod. Okay, sorry. Was entering and it was coming out because I had not given flag of interactive basically. So IT I need to give to get the basically terminal of the pod. Basically. So now I am into that one of the pods. So we can see Nginx pod we are here. We can see we are into the root directory. Now if I do ipconfig, ipconfig is not there. Anyway, so we have this pod, we are connected already and we have this IP. So we'll try to connect to or ping to another IP, which is the second pod. So let's see ping command is already available with this. Right. Right. Okay, let's try to get that. Those are not there. So to install. See what's the name. So this IP is ping. So that is for the ping command. I'm installing that. So curl we installed, CURL we installed ping, and let's install the IP config also to check the IP. So mask the IP and all. So let's spelling. Yeah, it's not giving the name. 1 minute. Okay, fine. We'll see that. Not an issue. We'll install that. First, let's try to connect to that another IP and check whether we are able to get that. So this was the IP of another port, the first port. So let's go up and verify. So first port is ending with 62. The another port, which is currently we are into that one, it is 41. So we'll ping that. So it means the theory what we discussed, like two pods can communicate with each other. Now it is true. Like I'm into one pod and I'm trying to ping to another pod. So directly I'm getting a response. Even I can try with C URL and I'll be getting a response from the Nginx server. So, thank you for using Nginx. So we are getting this response from the first pod, which is running a Nginx server. So that way we can tell we are like one pod is able to communicate with another pod without needing anything else. But the thing is only we need to know the IP address. Okay, so now let's move towards the next part, like creating a deployment. So as we saw, I did it twice. Like I need to create two pods. So I did it manually, like I created one and another one by one. So if we need to create a 50 instances, so that need to be done 50 times. But to solve that problem, we have a deployment. So let's go and check deployment, how to write and how it creates a two pods automatically or three pods, whichever we want. Okay, so let me here. Okay, so first let's delete the existing ones. And then we'll delete another one also. So let's check. There should be nothing. So all deleted. So now we'll create a simple deployment in which we'll giving the same, like same image we'll be using, but we'll be creating a multiple pods, like replicas of this one here directly, and we'll deploy. So let's name it simple deployment.yml. Okay, so save a little bit of time. What I can do? Okay, better. Okay, I'll write it down. So if you notice here, we are giving a kind, previously it was pod, now we need to give a deployment. So deployment, as we discussed, it is a kind of manager, but in Kubernetes term, it is called a controller. We'll not go into detail of what is controller and all that we can discuss in future sessions. But yeah, so that is the kind of manager which manages all the pods which is created by or managed by this deployment. Data. We need to give a name. So suppose we can give a demo deployment. Okay. And then we need to give a specification. So which comes in the spec. So first thing we need to give us a selector. Then we need to give a like a specification of the pods to be created. So we need to give a selector. Selector is basically matching the labels in like which label to match and create manage the specification. So selector labels. Here we can give any name of our choice. I'll give app and I'll name it engine X app. Okay. Now we need to give like how many replicas we want to create. So like how many instances basically of this container, basically a pod need to be created. So that we can specify with replicas. So I'm giving suppose 3. So it should create 3 replicas of the same application, basically the Nginx. We'll see that. Then we need to give a template like which container, which image and all it need to pick it. So that is, so this is the way we specify in deployment. Template. Need to specify metadata and labels. It should match with whatever we gave in the selector. So labels we can give and we need to write same. So app, I'll be writing that. Next. And then we need to give the spec, like how many containers enough. For simplicity, again, we'll be keeping only 1 containers per pod, but we need to specify like which image it need to pick and which ports it need to be exposed. So containers. Name. Demo. We will give image. Next. So if we are not giving any tag, it takes the latest one. So let's use the latest one. Again, ports we need to specify. So container. Will be keeping the default IP. So that's a deployment we created. Now, once we deploy this one, like once we submit this to Kubernetes, we should be seeing 3 pods running under the same deployment. So let's apply. So deployment created. Deployment we can verify with kubectl get deployment. Like how many deployments we have. So we have deployment 3, it is telling, it means it created 3 replicas of that. So 3 pods we need to have it. So let's go ahead and check. So we have 3 pods running as we were discussing. Now to access these pods, we can either go one by one, like all the IPs and all, we can check it and we can communicate with each IP, which is not a feasible option in a large scale system. So definitely we need to have a service. So we can verify like these are the IPs and we can communicate with these IPs, but we'll be creating a service for this and then we'll try to access that. So to link to that service, what we need to do, we need to create a service and basically the labels which we gave, that same label need to be given to a service so that it can connect to which it can apply to a particular set of pods. So what we'll do, let's check the label name. So we had used a label app Nginx app. So we'll be needing this label to link the service to a set of pods, basically. So let's do it. So let's create a service. Okay. I'm giving it a cluster because by default it will be cluster IP and we are creating a cluster IP service. So cluster. Okay, what I'll do to save time, I'll copy paste. Now lost. We need to indent it. I did. Port, any name we can give here. Name of the port. This is by default TCP, it's not mandatory field. So we can keep it or ignore it, doesn't matter. It's related. Protocol. So the port. So port means on which port this particular services will be accessible, and target port is the ports which we will be connecting, basically which this service will be sending the request or distributing the request on which ports the particular, like all the setup ports are running. So that's that port. So we were running on 80 port, and let's keep it same only. Like the service also will be able to access this service on port 80. So that is fine. Now let's change label which we had Nginx app. So now we are ready. This should be able to apply this. Fine. So it is created. We can view it. So get kubectl get service. So if we don't give anything, like all the services in the default name is this, it gets fetches and gets. So basically by default this Kubernetes will be available. We created this, the second one. So we can see the type is cluster IP and it is having its own IP address. It is not having external IP. It means we will not be able to access this service or this particular application from the outside of this cluster with the help of cluster IP. That will be doing using node port and load balancer that we'll see next. So now this service is created and we can see like this service is applicable for all those ports which we created. Basically, it's linked to that one. So how to verify that? So let's check the IP of the ports. Port. So we can note down these IPs and we can check to which all ports this service is linked. Basically, to which end port it is serving or load balancing that we can see. So for that, what we need to do, kubectl describe service and name of the service we need to give. So if we verify the endpoints, we can verify the IPs. 37, 137, 41, this is the IP. Port 80 it is pointing. This is another, the first one, and this is the third one. So it means if anyone accesses this particular service endpoint like this IP and port 80, it will be internally redirected to one of the ports, basically. Okay. So now, okay. So we saw this one, but still we will not be able to access this from the outside, because if we can see that, as we saw, like this particular IP is not having external IP, and we will not be able to access it from the outside. Same thing happens with the node port, but the node port creates a port on a particular node, and we will be able to access that node from the, if it is in a public network, we'll be able to access that particular node from outside, and then we'll be able to access this internally, this service. So we'll see the node port, and then we'll go with the node balancer part. So let's first delete this service, and we'll create node port and then try to access from outside of cluster. I'm creating a copy of cluster service. I'll name it as node service. Okay, so just I need to change the type to node port. And name we can use node port. System. We have one more option here in case of node port. We can give a node port here, but the port number should be in the range of the 30,000 and 32,000, that 768. Within that range, it needs to be there. So we can give any. If we don't give this one, then Kubernetes by default, it selects one of the port number within that range and it assigns. But if we want to use it from outside or some application, definitely we need to know this port. And if it is random, we need to change that at the client side also. So for that simplicity, let's write it here, 30306 name, the port number. So by default, it will be. So when we deploy this service, it gets a number, like port number will be 30306. Okay, so we don't have any service currently running. So skip secure, get. Okay, it's a default one. Let's go ahead and deploy this port. Port. So node port service created. Now let's query it, a bit of information. So we can see it is having a IP, cluster IP, but still it doesn't have any external IP. It means directly we cannot access this node port service. It goes through a IP of node, basically. So what we'll do, let's see like which all it is serving, which all the ports basically it is serving. For that, what we can do, keep secure, describe, again we'll do describe. It should be similar to what we saw for the cluster IP, but it will have few more information that we'll see. So again, we can see it is still pointing to same set of IPs because we gave the selector. The selector is still the same. This is a selector. So it means it is pointing to all the ports with this label. We have a type node port, and we can see we have a node port here. It should be there, which the number node port. So it means we'll be able to access this this service from this port using one of the IP of the node. So let's verify. So for that, what we can do, we can access it, but currently this cluster is not directly in public network. So directly we will not be able to access that particular IP of our node. So what we'll do, I have created another VM within that same network, and that VM we can connect it from the outside. So we'll log into that particular VM, and then we'll be using internal IP of the node to access the particular port. So let's see. So for that, we'll do first, let's get the IP. Let's sit here. Okay, need to note it down. So I will connect it to another, and I'll be able to access those, like these IPs from that particular VM. This VM is running in another, like it's running in the same virtual network, but it is accessible from the outside. So for that, let's take one of the IP. And then let's try to access from the URL. And then we'll give it port. So we got it again. So it means node port is working. We are able to communicate with the application using node port service from outside of the cluster. Okay. But still, as we discussed, it is having few limitations. We'll see how to create a load balancer part of the service and how we can access it from the outside. So let's go ahead and create load balancer now. So let's delete it first, node port part, and then we'll create a load balancer. Delete. Deleted. So now we will just again create another copy of this, and I'll give it a load balancer name. So now we need to change the type to load balancer. So when we give a load balancer type, what happens in case of cloud providers? It automatically provisions external load balancer, and it links with that to this node port. So basically that node port, we need not to do any configuration from our side. So that's where this load balancer type helps. It automatically provisions external load balancer, and all the configuration, port mapping, and all it's handled by the cloud provider only. But if we want to deploy our own load balancer, so in that case, we can use node port and we can do it manually. But all those things are automated when we create a load balancer type. So let's go ahead and create load balancer service type. So I'll keep it same. I'll just change the name. In this case, well, let's see. Here. Load balance. Name is wrong, but it's fine. Okay, so keep secure, get service, white. So now we can see it is having external IP here. So it means now we'll be able to access this particular load balancer or applications which is getting served by this load balancer service from outside of network. And let's see like what all the ports still it is serving. It's still serving to the same or not is pointing to something else. So let's check it. Again, we describe it and see. So, service. So if you remember, still it is pointing to all those set of ports. And we can see that target port is 80. Node port, it automatically shows. So internally it is managed. It means from the external load balancer, when the request comes here on port 80, it will automatically map to port 31682 of the node port. And after that, it goes to one of the ports. So let's verify. Copy it. Paste it. Yeah, welcome to Nginx. So we are able to access it. And this is coming from one of the pod. Out of those 3 pods, like one of the pod just gave this response. And we are able to see. Okay, so let's go to and check few things to understand. So we saw and go to console. So all those things, whatever we are seeing from the command line, we can go to console UI and we can see like most of the information, it will be available from the UI as well. So if you go to resources, we are able to see demo deployment, which we created. We have it already. Pods, all the pods we can see, and we can verify like it should be matching with those pods and all. Deployments, we created this demo deployment. So we are able to see here. Service and networking, we can see. So this is a load node balancer service we created. Okay, so we did deployment, we connected to pods, we accessed service from the outside. So that's all with this demo application, which we deployed, and that's all with the session. If any question, if anything is there, you can contact anytime at contact@imesh.ai. Thank you.